This is the fourth in a four-part series on the basics of statistics, describing a given collection of data. Part 1 considers the measures of central tendency. The three measures are defined, along with the method for finding each, and examples are provided. Part 2 considers percentiles, specifically the quartiles. We define the measures, learn how to find them, and look at examples. We also consider other measures to describe a set of data. Part 3 considers creating a box and whisker plot to provide a visual depicting all the measures defined in the earlier parts of the series. Part 4 considers the measures of spread, specifically the standard deviation. This measure is defined, as is the method for finding it. We look at an example in detail. In earlier resources, we discussed the measures of central tendency, mean, median, and mode. These measures give an idea of the typical member in a collection. This gives an incomplete picture of the overall set of numbers. It is also helpful to look at the measures of spread, which give an idea of how closely packed are the numbers in the list. We have already discussed the range and the interquartile range. However, the most powerful of these measures of spread is the standard deviation. The standard deviation is the average distance from the mean for all the values in a list. Like the mean, the symbol used for the standard deviation is a lowercase Greek letter, in this case the lowercase sigma. The formula to find the standard deviation involves some heavy-duty mathematics notation. The formula for finding standard deviation for a set of values with mean mu is the square root of the quantity, the sum of the differences between each individual value and the mean, squared, divided by the number of values. This formula is a little scary and can be overwhelming. Fortunately, we can create a chart of values that will make it easier to break the formula down into steps we can attack one by one. First, we need to find the mean of the values. In the next column, we subtract the mean from each value. We then square each of those differences. We average those squared values. We finish finding the standard deviation by taking the square root. Let's look at an example. Our favorite Empire State student, Sam, got scores of 50, 80, 70, 30, and 70 on their submitted assignments. The instructor is concerned that Sam's scores are too spread out to give a true indication of Sam's learning. They want to add some context to the average Sam receives as a grade, so they decide to find the standard deviation to give an idea of the spread of Sam's scores. To start, we need to set up a table of values to ease our calculations. We insert the scores in the first column. Because we know that we need the mean, we add the scores to get a total of 300. Dividing by 5, we find that Sam's average is 60. We subtract the mean of 60 from each of the scores. This gives us variations of negative 10, 20, 10, negative 30, and 10. If we add these variations together, we get a total of 0. This is not a coincidence. The sum of the individual variations from the mean for an entire set will always equal 0. Now, we square each of the individual variations. Negative 10 squared is 100, 20 squared is 400, 10 squared is 100, negative 30 squared is 900, and 10 squared is 100. Adding those squared values together, we get a total of 1600. Dividing by 5, we have an average variance of 320. Taking the square root, we find that the standard deviation is 17.89. For a small sample size, this is a rather high standard deviation. The instructor concludes that Sam's scores are not very consistent, and that while Sam will receive a score of 60, that doesn't truly represent Sam's mastery of the subject.